Once again, good morning class. I am Teacher Joker from Wachukachu School. I am currently handling grade 5/1. For today, our subject is mathematics and our topic for today is about the types of fractions. Are you ready? Okay, so I hope everybody's ready. So we're now going to start our lesson for today. Before we start with our new topic for today, I would like to have a little review first on our previous lesson, which is about the combined operation. Okay, so when we say combined operations, this is a problem using two or more operations. And by the way, what are the four basic operations? We have division, multiplication, addition, and subtraction, right? So going back to our topic, which is combined operations, in a problem where it uses two or more basic operations, that is what you call a problem involving combined operations. Like for example, the problem that we have there in the screen, which says 34 times 2, subtract 5 plus 20. Okay, there are three basic operations that was used in there, right? We have multiplication, subtraction, and addition. Therefore, that is a problem that involves combined operation. Okay, so that was our previous lesson. Okay, now let me introduce to you our topic for today, which is fractions. Okay, so what is fractions, by the way? When we say fractions, these are numbers that represents a part of a whole. A fraction is written in the form of 3 over 4. Okay, so a fraction, in order for us to write a fraction, we need to use a line to separate the numerator and the denominator. It is a way of writing numbers that are not whole numbers. Okay, so that's about fractions. So again, fractions are numbers that represents part of a whole. And we have here the vocabulary for today. First is we have numerator. Again, numerator. When you say numerator, this is the number above the line of a fraction. So in writing a fraction, we use line, right, to separate the numerator and the denominator. And the numerator is the number above the line, while denominator is the number below the line. Okay, so later on, I will be showing you some examples of this. But these are not new to you, actually, because we learned already this one. And our next vocabulary is a proper fraction. Improper fraction, mixed number, greater number. Okay, when you say greater number, it means bigger number. Smaller number, or let's say lesser number. So these are some few of our vocabulary on this topic. Type of fraction, which is proper fraction. When we say proper fraction, it has a numerator that is smaller than its denominator. So a proper fraction has a numerator smaller than its denominator. Okay, so I will be showing you an example on the next slide. So this is now the example of a proper fraction. It has a numerator smaller than its denominator. Okay, example there is we have here 2 over 3, or 2/3. Okay, this fraction has a numerator of 2 and a denominator of 3. And when we said that proper fractions has a numerator smaller, so if you notice, 2 is smaller than 3. Therefore, 2 over 3 is a proper fraction. Okay, next example is we have here 3 over 6. Okay, 3 is smaller than 6. Therefore, 3 over 6 is a proper fraction. Another example, 5 over 7. 5 is smaller than 7. Therefore, 5/7 is a proper fraction. And last example, we have 16 over 40. 16 is smaller than 40. Therefore, it's a proper fraction. Okay, again, when we say a proper fraction, the numerator has a smaller number than its denominator, or the numerator is smaller than the denominator. Okay, got it? So that is the first type of fraction, which is proper fraction.
Welcome to Math with Mr. J. In this video, I'm going to be covering proper fractions and what they are. Now, when it comes to proper fractions, these are fractions where the numerator, the top number, is less than the denominator. So proper fractions have a value that are less than a whole. So let's jump into a few examples here in order to better understand proper fractions. Number one, we have 2/5. So we can clearly see that the top number, the numerator, is less than the denominator. So this is a proper fraction. Now let's model 2/5 to prove that it's less than a whole. Now to the right of this, I have a whole rectangle cut into fifths. So let's fill in 2/5. This would be 1/5 and 2/5. So you can see that we have less than a whole there. That fraction represents less than a whole, therefore a proper fraction. On to number 2, where we have 3/4. So again, our numerator is less than the denominator, and this represents a value less than a whole, so we have a proper fraction. So let's model this, and we have a circle here cut into fourths, so we need to fill in 3 of those. So 1/4, 2/4, and 3/4. So you can see that we have less than a whole there. And on to number 3, where we have 4 choices, and we need to pick out the proper fractions out of those 4 choices. So choice A, we have 6/6. So the same number, same numerator as the denominator. So in this case, the numerator is not less than the denominator. So if you have the same number on top and bottom, same numerator and denominator, it's actually considered an improper fraction. So A would not be a proper fraction. B, we have 17 over 33. So our numerator is less than the denominator. Therefore, we have a fraction that has a value less than a whole, and it's a proper fraction. So B is a proper fraction. C, we have a numerator that's greater than the denominator. So that's what we call an improper fraction. So C would not be proper. And then finally D, 1 over 65. So our numerator is less than the denominator, therefore we have a proper fraction, and that fraction holds a value less than a whole. So there you have it. There's a brief introduction to proper fractions. I hope that helped. Thanks so much for watching. Until next time, peace.
Okay, next type of a fraction is we have here improper fraction. When we say improper fraction, an improper fraction has a numerator that is equal to or greater than its denominator. Okay, I read it again. An improper fraction has a numerator that is equal to or greater than its denominator. And an example of improper fraction is we have here 5 over 4. Okay, why is it that 5 over 4 is an improper fraction? We mentioned a while ago that if the numerator is greater than the denominator, that is an improper fraction. Or the numerator and the denominator are both equal, that is an improper fraction also. Okay, so if we're going to look into these numbers, 5 is greater than 4. Or the numerator, which is 5, is greater than the denominator, which is 4. Therefore, 5 over 4 is an improper fraction. Okay? So that is improper fraction.
Welcome to Math with Mr. J. In this video, I'm going to cover improper fractions and what they are. Now, when it comes to improper fractions, these are fractions where the numerator is greater than or equal to the denominator. So the top number is greater than or equal to the bottom number. Improper fractions hold a value equal to or greater than a whole. So let's jump into a few examples here to help us better understand improper fractions. In number 1, we have 8/5. So you can see that our top number is greater than the bottom number. Therefore, we have an improper fraction. Let's take a look at modeling this fraction to show how it is greater than 1 whole. So 8/5, I have 2 whole rectangles to the right here. So we need to fill in 8/5. Each rectangle is cut into fifths, so we need to fill in 8. So for example, this would be 1/5. Then we have 2, 3, 4, and 5. So right now we're at 5/5, 5 out of 5 filled in. And I want to mention, whenever we have the same number up top as we do the bottom, when it comes to fractions, we have an improper fraction, and that fraction equals 1 whole. So whenever you have the same number on the top and bottom, it equals 1 whole. But we need to continue here for number 1 because we need to get to 8. So this would be 6, 7, and 8/5. So you can see that we have 1 whole rectangle filled in, and then 1, 2, 3/5. So 8/5 equals 1 3/5. And we can see that that has a value greater than 1 whole. It's an improper fraction. So let's take a look at another example. For number 2, we have 9/4. So 9/4, the numerator, the top number, is greater than the denominator, the bottom number. So we have an improper fraction. And this improper fraction's value is going to be greater than 1 whole. If we were to have, I want to mention this again because it's important, if we were to have 4 over 4, remember, same number up top and below equals 1 whole. But in the case of number 2, 9/4, that top number is greater than the bottom, so this is going to be greater than a whole. And let's model this one. So we have holes to the right here, whole circles, and they are each cut into fourths. So we need to fill in 9/4. So 1, 2, 3, and 4/4. So you can see 1 hole there. 5, 6, 7, 8, and 9. So we have 2 whole circles filled in. And then right here, we have 1/4. So 9/4 equals 2 1/4. So I want to mention that this is an improper fraction. Now, right over here where we have a whole number and a fraction, that's called a mixed number. And improper fractions and mixed numbers are equivalent. One is just in complete fractional form, and then the other shows the whole number plus the fractional form. But 9/4 and 2 1/4 are equivalent. Just like number 1, 8/5 and 1 3/5 are equivalent. So as far as number 2, I'll wrap this one up by saying that we proved that 9/4 is greater than a whole there. And again, we had an improper fraction because the numerator was greater than the denominator. So let's move on to number 3, where we have 4 choices, A, B, C, and D, and we need to pick out which ones are improper. So let's start with A, where we have 6/6. So our numerator, the top number, is the exact same as the denominator. Therefore, this fraction equals 1 whole. And in the case of this, our numerator is equal to the denominator. So we have an improper fraction. Choice B, we have 17 over 33. So the numerator is less than the denominator. That's what we call a proper fraction. So this is not improper. Now choice C, Our numerator 42 is greater than our denominator of 20, so we have an improper fraction there. And lastly, D, we have 1 over 65. So the numerator is less than the denominator. Choice D is proper, therefore not improper. So there you have it. There is a brief introduction into improper fractions and some examples to show exactly what they look like and what they are. So I hope that helped. Thanks so much for watching. Until next time, peace.
The third type of fractions is we have mixed number. Okay, when you say mixed number, it consists of a whole number in a proper fraction. Okay, it consists of a whole number in a proper fraction. So it's a combination of a proper fraction and one whole number. Okay, so let's see some of the examples. An example of mixed number is we have here 2 and 1/3. Okay, 2 and 1/3. As what I've said a while ago, mixed number consists of one whole number and a proper fraction. Okay, our whole number in this fraction is 2. And our proper fraction is 1 over 3 or 1/3. Okay, so it's a combination of a whole number and a proper fraction. That is what we call mixed number. So 2 and 1/3 is an example of mixed number because it consists of one whole number and a proper fraction.
Welcome to Math with Mr. J. In this video, I'm going to cover what are mixed numbers, and we have two examples that we're going to go through together in order to get this down. Now, mixed numbers are whole numbers and a proper fraction together, so a whole number plus a proper fraction, and they help us represent values in between whole numbers. So let's jump right into number 1 here and see what I'm talking about. So like I mentioned, we have a whole number and a proper fraction. So we have 1 and 4/5. And this particular mixed number represents a value in between one whole and two wholes. So let's model this mixed number and then also place it on a number line in order to help us visualize and really understand what mixed numbers are. And we'll start with the model. So we need one whole, and let me back up here. I have two rectangles here, so this is where we are going to model. So we need one whole rectangle filled in to represent that one whole. So let's fill in one whole rectangle. Now I filled in 5/5 there. Each rectangle is cut into fifths. I had 1, 2, 3, 4, 5 sections out of 5 sections filled in. So that also can be written as 5/5, which is equivalent to one whole. Now we need to represent the 4/5. So this would be 1 and 1/5, 1 and 2/5, 1 and 3/5, and then 1 and 4/5. So there is our model. And again, this is a value that is in between one whole and two wholes. You'll notice that we almost have two wholes there, but not quite. So let's place this mixed number on a number line next. So we'll start by finding one whole, which is right here. Then we need the 4/5. So this would be 1/5, 2/5, 3/5, and 4/5. So we would place 1 and 4/5 right here. And again, you'll notice that we are in between two whole numbers, 1 and 2. Now I do want to mention that mixed numbers can also be expressed as improper fractions. And an improper fraction is a fraction where the top number, the numerator, is greater than the bottom number, the denominator. Mixed numbers and improper fractions are equivalent. They can represent the same value. It's just two different ways to write out that value. So for example, number 1, 1 and 4/5 is actually equivalent to 9/5. So we could take a look at our model, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9/5 filled in. So we can see that 1 4/5 is equivalent to 9/5. Now there's another way to convert between mixed numbers and improper fractions, but that's a topic for another video. I'll drop other links to improper fractions and other fraction topics down in the description. So let's move on to number 2, where we have 3 3/4. So again, a mixed number, we have a whole number plus a proper fraction. So let's model this first, and we first need to fill in 3 holes. So we'll use circles this time. So 3 whole circles to represent the whole number. And then the proper fraction portion, we have 3/4. So 1/4, 2/4, and 3/4. So that would be 3 3/4 modeled there using whole circles, and then our proper fraction portion 3/4. So over to the number line, where we need to start with the 3 holes. So 3 holes is right here, and we need to go 3/4 now. So this would be 1/4, 2/4, and 3/4. So we would land right here, and that would represent 3 3/4. So you can see that 3 3/4 represents a value in between 2 whole numbers, 3 and 4. Now 3 3/4 as an improper fraction, let's write that out, is going to be, let's see, 1, 2, 3, 4. We have 4/4 there, 4/4 here, 4/4 here, and then 3/4. So 4, 8, 12, 15/4. So we have 15/4 filled in. So again, those are equivalent. Mixed number 3 3/4 equals 15/4. Just 2 different ways to represent a value. Mixed numbers and improper fractions hold the same value. Again, just 2 different ways to represent a value. So there you have it. There's an introduction to mixed numbers. And like I mentioned earlier, I do have other fraction videos that go off of this video. I dropped all of those links down in the description. So I hope this helped. Thanks so much for watching. Until next time, peace.
Now let's summarize our topic, which is types of fraction. Okay, first type is we have proper fraction. Second is we have mixed fraction. And the last one is we have improper fraction. So those are the 3 types of fractions: proper fraction, mixed number, and improper fraction. An example of proper fraction there is 3/4. Why 3/4? Because the numerator is smaller than the denominator. Next is 2 3/5. Okay, why is it that 2 3/5 is a mixed fraction or mixed number? Because it consists of one whole number and a proper fraction. So again, the whole number there is 2. And the proper fraction is 3/5 or 3/5. Okay, next is we have here 5/3. 5/3 is an example of improper fraction because the numerator 5 is greater than the denominator, which is 3. Okay, so that's the difference between the 3 types of fractions.
Hello and welcome to Common Core for Kids Nightly News. Tonight we have a very special report on someone amazing. That would be me, of course, the number 1. Let's take a look at the news story that happened to me today. Today I really need your help with learning some basic fractions. I have these shapes that my friends and I wanted to play with, but we had a problem. Every time I divided the shape to share it, one of us got mad because we did not get as much as the others did, and it did not seem fair. This is why we are learning about fractions today, so I can know how to make it fair for everyone. Here is a circle, and there are 3 of us who want to share the circle, so I broke off 2 pieces and gave them to my friends. They did not think that was fair. What do you think? Do we each have even pieces of the circle? We do not, and that is something important about fractions. To be a fraction, you have to have equal pieces. Right now, we do not have equal pieces, so this cannot be a fraction. Let's try this again with another circle. All right, here we have another circle, and I am going to divide this whole circle into 3 pieces. Now we have 3 pieces, and guess what? They are all equal, which means all 3 of us get the same amount of the circle. This is really cool stuff. I did not know I liked fractions this much. A fraction represents a part of a whole. The green part of the circle is mine to play with. I have one of 3 parts of the circle. We call this a third. I have 1/3 of the whole circle. When we write fractions, they look like this. We have a number with a line in the middle and another number underneath. The number on the bottom always shows all the parts of the whole circle. In this case, we have 3 parts that make up the whole circle, so we have a 3 on the bottom. Now on the top, we have the number 1. If you look at the third of the circle that is colored green, you will see that there is just 1 part. This is my part of the circle. The number 1 on top represents my part of the circle. I have 1/3 of the whole circle. Okay, my friends went home and gave me back their parts of the circle. Now I have all the parts of the circle. I have what we call 3/3 of the circle. I have 3 parts over the total, which is 3 parts, which means I have 3/3. This also means I have the whole circle all to myself because I am not sharing any pieces, so the 3/3 that I have are mine right now. Now I have a rectangle, and it is just 1 piece. Oops. It looks like I have more than 1 piece now. I have 2 pieces, and they are equal to each other, so we have a fraction. I have 2 pieces which make a whole. One of these pieces makes up half of the whole shape. Together, I have 2 halves of the whole shape. That is awesome. Here is another circle, and I divided this circle into 4 separate parts. Right now, I have 4 pieces over 4 pieces. We call these 4/4. There are 1, 2, 3, 4 pieces, which gives us 4/4. But...
Hey, I want one. Me too. Me too.
I have 3 sisters that want a piece of the circle. I have 1/4 of the circle, but can you tell me how many fourths of the circle my sisters have? They have 3/4 of the circle. These fractions are easier than I thought. Thank you so much for helping me today. Now I better give the 3/4 to my sisters, or there will be trouble. Goodbye. Thank you for watching. Please share the video and subscribe.
But what if a fraction is being represented by a diagram? Okay, if a fraction is being represented by a diagram, like for example, we have here a fraction which is 2/7. Okay, look at the diagram on the left side. Okay, if we're going to count the pies over there, we have 1, 2, 3, 4, 5, 6, and 7. Okay, so the number of pies there is 7, right? Okay, so that will be the denominator. And the colored one, which is 1 and 2, will be the numerator. Okay, so if we're going to represent 2/7 in a diagram, it will be like this. Okay, Now, next example here is we have 1 and 3/4. If we are going to represent 1 and 3/4 in a diagram, we need to have a one whole, okay, that represents 1. Okay, so we have one circle over there, and 3/4 is being represented by 3 colored columns, and 4 refers to the number of columns in one circle. Okay, 1, 2, 3, and 4. Okay, there are 4 divisions in a circle, or 4 pies in a circle. So that will be the denominator. While 3 refers to the colored divisions in a circle. Okay, so that's 1 and 3/4. And another examples we have here a fraction which is 1/8. So 1/8 is being represented by the diagram on the right side. So that represents the fraction 1/8 or 1/8. And last example, we have here one whole. So the first circle is a whole. Okay, it's a complete whole. While the second one, it was divided wherein it is 1/2 or 1/2. So if we're going to divide a whole, that will be a half or 1/2. And divide the half, that will be 1/3. And divide 1/3, that will be 3/4 or 3/4. Now let's have your activity for today. For your activity, I would like you to answer page 13 on your workbook. So you're going to write the fractions that being represented by the diagram. Okay? So I showed you an example a while ago, so you can now do your workbook. So write the fractions that being represented by the following diagrams. So that is in your workbook. What page? It's on page 13. So that's all for today, class. Thank you for listening. I hope you understand everything. Okay, so if you have any more question about our lesson for today, please don't hesitate to ask me again in line or call me in line again. Okay, so please don't forget to do your activity on your workbook that is on page 13. So see you again this afternoon. Goodbye.